Our topic for interest for this video is merge sort. So what is a merge sort? Merge sort is a divide and conquer algorithm. As we saw in our previous video, we first divide the problem, we conquer it and then combine it. Merge sorts guarantee n log n performance for any type of input. If we compare it with quick sort, which give us a worst case running time of n square. Merge sort is a stable sort. So what does stable mean? So let's say we have an array like this. So we can see here we have a 5 here and a 5 here. So if the sort is stable, this element will always come before this 5 in our sorted array. So merge sort help us have a stable sorting. Unfortunately for quick sort we don't have such. We will learn how merge sort work using an example. So here in our example we have 12 elements of an array. So as we recall from our previous lecture, the steps involved in divide and conquer. So the first step is dividing. We have to divide our array. Let's see how we can do that. So we divide the element here into two parts. The first part has 6 elements, first 6 elements of the array. The second part has the remaining 6 elements. Similarly, we'll divide it again. Here, the first 3 here and the next 3 here. From our second sub-problem, we are dividing into more sub-problems. We will continue dividing into half. As long as we can solve it directly. So this is our sub-problem. As each sub-problem contain one element, it's all sorted. So this is our base case. We can sort each array by brute force. All our sub-programs are already sorted, so we have conquered them. So we have divided the problem into all the sub-problem. We have conquered the base case. As of merge sort, a single element is sorted already, hence we have conquered. Now we have to do the third step, which is combining all the sub-problem into our final problem. We will try to combine the first two sub-problem. So here we can combine them. Which one is smaller, 0, 0 or 82? 0, 0. Now only 82 remains, so we will be putting it. So if we compare this 0, 0, 82 and our sub-problem which we got in one of the back step, if we see the result of the sub-problem here and we compare with one of our previous sub-problem, we have conquered it. 0, 0 is less than 82. This problem is sorted. Now we do same for the other sub-problem 95. So there is nothing to combine. So we'll directly put 95. We have sorted this part. Now we move our attention here. We compare 11 and 38. Which one is sorted? 11. So we put it there, and 38 we have it here. So we have conquered this part of our problem. This is sorted. Similarly 98. Similarly we sort these two sub-problem. Now this sub-problem is sorted. This one as well, here and here. Our 11th, 10th and 11th sub-problem. This is also sorted. Finally 56. So we have basically completed the first combination of our merge sort. We continue the process. 0, 0, 82, 95. This is sorted. 11 is smaller than 98 and 38 is smaller than 98, and as nothing is remaining we put 98. This problem is sorted. 8 is 8 smaller than 34? Yeah, so 8. Now 83 and 34. 34 is smaller, 83 is the only remaining element, so we put it there. So this and this subproblem is sorted. Continue. 5 is smaller than 56, 40 is smaller than 56, as 56 remain. This is the only subproblem. So our second combination is, we move to the next combination. Now we'll combine this and this subproblem. So is 0, 0 is less than 11? Yes. And now we move to there. Is 82 less than 11? No. So we put 11 here. Now we have 82 and 38. So which one is smaller? Obviously 38. So we put it here. Now we have 98 and 82. As 82 is smaller, we put it here. 98 and 95. So 95 is smaller, we put it here. Now this array is over, so whatever remaining of this array, that is 98, we concatenate here. So this is solve half of our problem. If we see, this part is totally sorted. So the first 6 element we have sorted it. We check for the next one, 5 and 8. As 5 is smaller, we add it here, 8. Now 8 and 40, 8, 34, 40, 56, 83. The steps are self-explanatory, and hence we have achieved our mission of solving the other half. Now our final goal is combining both. Now we compare both the subproblem. 0, 0 and 0, 5, which is smaller? 0, 0 here. 11 and 0, 5, 5. So we put 5 here. 11 and 8, 8 is smaller, 8. Our pointer still lie in 11 and 34. Now 11 and 34, 11, we put it here. Now our pointer move to 38. 34 and 38, 34, okay. 40, now 40 and 38, we put 38 here. Now our pointer move to 82. Now we'll compare 40 and 82. 40 is smaller, we put 40 here. 56, 56 and 82, 56 is smaller, we put it here. 83, 83 and 82, 82 is smaller, so we put it here. Now our pointer move here to 95. 95 and 83, 83 is smaller, so we put 83 here. Now this array is over, so whatever remaining we'll just add it one by one. 95 and finally 98, and hence we have sorted the array using merge sort. Next important thing is runtime. We at the beginning we said it consume n log n. Now why is it important to understand how it consume n log n? In future we'll be designing many algorithms which are similar to merge sort, and we can use the same technique to solve many difficult problems. So if we know how we are able to achieve it in n log n time, we'll be able to design better algorithms. Let us take a look at the runtime of the algorithm. So if you see at this step, we have two subproblems. So we'll denote it by 2. And let's say, and every subproblem has n by 2 element in it. Now we can cancel 2 and 2. So it's n. So we'll go one step ahead. And here we have 4 subproblem. 1, 2, 3, 4. 4 subproblem, and each subproblem has n by 4. So still n here. In the previous step it took n step, and now we go one step ahead. Similarly 8, 8, 16, 16, and as long as we can go, and we will see that it's only depend on the n value. So the runtime will be n into the number of combines. So what will be the number of combines? As we are dividing it into 2 in every step, so we'll have a log to the power 2n number of steps. Our final runtime will be n log 2n, and